Hi everyone, welcome to our first virtual lesson. We are going to cover section 1.4 today from Accent on Algebra. This will be the last section in chapter 1. We are covering the distributive property today, but first let's get started with a warm-up. Your job is to identify the properties that are represented in the equations on the screen. You're welcome to use your notes from the last time we had class, and I'd like you to pause the video so you can do this, and then submit your answers to me using the link in the video description below. All right, so let's start with our lesson. We are covering 1.4, the distributive property, and bear with me as I learn how to use this whiteboard here. The date is 3/17/20. And if you don't already have your notebooks out, I want you to pause here and get it. This is going to be just like class, where if I write in blue, I want you to write it too. All right, so we talked a little bit about the distributive property the other day, but I just want to remind you that if I have some number A and I multiply it by two other numbers added together, the distributive property kind of distributes the number on the outside to the numbers on the inside. So I'm going to do A times B plus A times C. So that's A, B plus, and it's plus because of this plus over here, A times C. All right, so if I have 3 times, let's say, x plus 5, I would do 3 times x plus 3 times 5, or 15. All right, so you may be asking yourself, why would we ever use the distributive property? What is the point? Well, it helps us with mental math. So if I want to, let's say I want to multiply 56 by 101. This is a little tough to do in my head, but if I break up the 101 into 100 plus 1, I can rewrite this as 56 times, in parentheses, 100 plus 1. And then, in my head, I can pretty easily do 56 times 100 plus 56 times 1. And that's going to be 5,600 plus 56. So my answer is 5,656. And I really didn't need any paper to do that. So that's kind of the beauty of the distributive property. Let's do one more. What if I wanted to multiply 56 by 99? I could add up to 99. I could do, 50 plus 49, but that's not really going to help me. So I can use the same technique I used up here, but instead of adding 101, I can subtract 1 from 100. So I'd have 56 times 100 minus 1. And we're going to have the same numbers as before, except I'm just going to have 5,600 minus 56, and my answer will be 5,544. So the distributive property is pretty useful for us there. It also can be used to find areas. So I'm going to go ahead and erase this. If I have, let's say I have a rectangle here. And I'm just going to say that this side is going to be 8 feet long. And this side, I'm going to break up into 2 parts. I'm going to say that this longer part over here, this is going to be 40 feet. And obviously this is not drawn to scale. This little guy over here is going to be x. I don't know what x is yet. But I know that my entire area of this rectangle is 360 square feet. So I can use the distributive property to help me figure out what x is. And to make this a little clearer, I'm going to draw, a little dotted line along here to separate these two portions. So we know that we find the area by doing length times width. I'm going to be doing 8 first over here. I'm going to do 8 times the other side. And this other side is just 40 plus x. 40 plus x. And I know that this all has to equal 360. So now I can distribute 8 times 40 plus 8 times x. So that's going to be 320 plus 8x equals 360. We all know that we kind of have to get x by itself. So to do that, I'm going to subtract 320 from both sides. And I'm left with 8x equals 40. And if I divide by 8 on both sides, I find that x equals 5. So this little portion right here is 5 feet long. All right, wellness break. Time to stand up. Pause this video right here and do 50 jumping jacks. Let's get back to it. So the other part of this lesson is going to be about simplifying expressions. So we are going to take some expressions that are a little too long and we're going to simplify them because we know mathematics is very concise and mathematicians like to say things in as few words or variables as necessary. So let's say I have an expression like 2y plus 3 plus 6y. All of these things separated by plus signs are what we call terms. So 2y is a term, 3 is a term, and 6y is a term. So these are all terms, and make sure you are writing these things down as well. But there are two terms in here that we call like terms. So 2y and 6y are what we call like terms because they are alike to each other. So these are like terms. And we can combine terms that are similar. So 2y and 6y add to 8y. So I'm going to erase this here and rewrite 2y plus 3 plus 6y. And I like to underline any like terms when I come to an expression. So I will underline 2y and 6y. And I also like to underline the operation that comes before any terms because that's what's going to tell me what to do with it. The plus 3 here is not like 2y or 6y, so I'm going to underline it twice. So this is going to come out to 2y plus 6y, which is 8y plus 3. And I can't add 3 to 8y, remember, because this is like saying I have 8 apples and the number 3. I can't add the number 3 to 8 apples. So this is how I'm going to leave my answer. This is a simplified version of this original expression. Let's give another one a try. So let's say I have, let's see here, let's do 9p plus 3w plus 7 plus 8p. And go ahead and underline the like terms here for yourself. I'm going to underline 9p and plus 8p because that's what it's going to tell me to do with it. I'm going to underline plus 3w with 2 underlines and the plus 7 because it's even different from 3w with 3 underlines. And I'm going to combine what can be combined here. So that's 9p and 8p. So that's going to be 17p plus 3w plus 7. And that is my final answer. I can't go any further with that. I'm going to give you a few to try on your own. So I'm going to erase this here. And let's say we're going to have A and B for you to try on your own. So I'm going to do, let's say, I'm going to have 9p again, but I'm going to do minus 3w plus 8w minus 10p. And down here, I'm going to have, let's say, 16 minus 6m plus 2. So go ahead, pause the video right here. I want you to give these a try on your own. Okay, so we're back. I'm going to underline my like terms here, 9p minus 10p, and then I have minus 3w, which I'm going to treat like a negative because I'm starting off with a minus, and plus 8w. So this, all in all, is going to come out to 9p minus 10p. That's going to be negative 1p, or you can even just write negative p. And then I'm going to have negative 3w plus 8w. That's going to bring me to positive 5w. And if you end up with a positive number, that's going to tell you that you should be using a plus between those. If you end up with a negative number, that's going to tell you you should have a minus between these two terms. So this is as far as I can go with this expression. Down here, this one is actually a little more straightforward. So 16 plus 2, those are both just numbers. And minus 6m is not a like term. So I'm going to have 16 plus 2, that's 18, minus 6m. And that is simplified. All right. This brings us to the end of our lesson. Thank you so much for joining me. Please refer to my email for your homework, and I will see you next time.